97.19%. So now another exercise is that, example number 3. Now the company have become frustrated and with the delay order, and customers he filed a complaint because previously the company tell 30 weeks 30 weeks the probability is 30%, but now they have a customers come frustrated and because of delay and told the company if the new ordering system is not working within 22 weeks, it will not do any more business with the textile company. So means the earlier case is that the company promised 30 weeks, but the delivery keep delay. Then the customer come back to make more demand, more requests that say, can you work on 22 weeks or not? If not, I'm not going to do business with you. Okay. So previous example is 30 weeks, probability is 97%. So now, what is the percentage if the customer change to 22 weeks? Will you able to make it or not? Just now from the network analysis just now, you draw the 6 rubrics, maximum is 25 weeks. Now customer want 22 weeks, can you make it or not? By logic, cannot lah. Why? Because your critical path is how many days? So you need to calculate also a critical path. But from the project's network just now is 25 weeks. So customer requests something that below the maximum time that you need to find. So we need to tell the numbers to the boss, to the sponsor, and also to the customers. So it means your process line, you need 25 weeks, but now you request 22. So what is your probability of delivering the request? Okay. So what you do, start the same with the same equation. You start with z equal to x minus mu divided by sigma. So now what is the value of your x? 22. X now become 22 already. So your mu here is your project mean time. Just now from the network analysis is 25. Sigma is 2.62. You calculate from the sigma square value. So the z is minus already. Where is the location? Just now the positive number. Now you get negative number. So it's on the left hand side of the graph. Yeah. Hope you guys understand the graph. So this one is positive side, this one is negative side. If you get z more than positive is over this side. If you get less than negative is on the left hand side. So now you have a negative 1.14 is on the left hand side of this one. But from the diagram here, you can straight away find 1.4, like what you mentioned just now, you can use the value without using the interpolation. 1.14 is about 0.3729. 15 okay lah. 15 chun or point something. Or 5, okay lah. Okay lah. Okay. So it's at the another side. So again, it's about 3729 about here. Or if you 5 is jump to 2749 already. Okay. So yeah. So if you are if this question come out and you found that your number is z equal to 1.145, you just write 1.145 and then you write the third 3 numbers first, and then because here only have 2 numbers 2 decimal 1.145, you summarize to 1.5. You explain like this in your answer. Okay. Something like that. So you don't straight away jump to 1.15. Because when I'm marking, I rarely go into very deep. I just compare my scheme, marking scheme and the answer. Unless there are more than 3 students that keep using 1.5, then I will look back into my marking scheme lah. Okay. Okay, so you have the 37.29%, right? Is on the left hand side over here. Okay. So probability of completing the project in 22 weeks or less is on the left hand side of the line. So what is the percentage of that one? So you know that this half is 50%. 50%, 22% is here. This is the 25 weeks. This is 22. So here to here, you find from the probability table is 37%. So this is the answer we're looking at. So you take 50% minus 0.5 minus this one, you get the 1.12, which is 12% or nearly 30%, 13%. Okay. So probability of completing project in 22 weeks is only less than very, very low, very, very low. Okay. So very high chances you are going to miss this customer if the negotiation not successful. Yeah, yeah. Yes, it's just that you try to convince yourself with convince the customers or your sponsor with numbers. Yeah, I mean you do your part lah. You just say okay, based on what our capability or our process is less than 12% or 30%, we managed to do. Okay. All right. So this is how you do, and then there's a function for projects using Microsoft projects lah. So there's okay. Previously it was free, but nowadays you need to purchase this one. Okay. Okay. So the next one is more on the additional information about PERT networks, right? Basically, you already learned from previous slides already. This is just an add-on. As you can see, this one is I extract this one from another textbook. So the previous one is from one textbook, this one another textbook, but it's similar ideas. So you have activities, you have time period, and so on. So this is PERT networks. So you have activities and you have numbers and so on. Okay. Then you have bus point, you have sync, and so on. Okay. So bus point means activity you split into more than 2 activity. If you are sync means if like everyone go into 1 point. So you have two sources, bus point and sync point. Okay. So the question might ask you from your network, identify where is the bus point, where is the sync point. So it will be like the electronics things, the input and gate. Okay. So this is quite straightforward. Another one is type of tools. Previously, we already covered this one previous lecture. This is just additional for you. Gantt chart, milestone chart, PERT chart. Okay, so you can convert Gantt chart, milestone chart into PERT chart. Okay, the rest you read. Okay, this is the network. How you do it, this step-by-step explanation, how you build the network. For example, you see this kind of table, activity 1 to 2, 2 to 3, 4 to 2 to 4, and so on. Then you label is title A to K. Immediate predecessors means you need to complete, for example, B, you need to complete A before you can do B. Okay, activity times. Okay. So from here, you can build a network. You can build a network. Depend on the question, whether the question want you to build AON or AOA. Okay. But most of the time it's AON. Because from AON, you can do a lot of analysis. And AOA will be more on construction projects. Most of the time, more on the construction. Okay, so this is the one that you're very familiar with. So from here, you have a process from 1 to 9 and so on. Okay. So how to find critical path? You find the longest time from the network. Okay. Another one is called CPM. So what is the differences? I give you all the point here. On the left is more on the PERT. PERT, you have the A, M, and B value. You have the optimistic, pessimistic, and the mean. But for CPM, you only use the mean estimate time. Okay. So PERT CPM, you permit the use of dummy to develop the logic. So PERT for R&D, CPM for construction, PERT for there's a milestone. Then CPM we use percentage of completion. Okay. So this something like that lah. This is a GERT network. We're not going deep into this one. We just introduce you what is graphical evaluation review techniques. It's more on the curve. There's a loop back and so on. Quite confusing this one. Okay, so we're not going to subchapter. So dependency is the dependency. So you have 3. Mandatory dependency is things that you cannot change. For example, erecting the wall of the house before putting the roof. You need the wall before the roof. Okay. So discretionary. This one is soft logic. It's based on what you experience. You think that, okay, this one can go first, then you do. External dependency, this one is outside the control. Outside the control. For example, delivery of some material. Okay. Slack time, you already know. Slack time, you take the latest date minus the earliest date. This one you or from the 6 rubrics or 6 boxes, you take the last 2 minus. This one just additional revision for slack time. Okay, so this is another textbook calculation. Same, but a bit messy. So the one that we learned earlier with the 6 boxes one is more order, more well arranged, but it will still reach the same objective. Okay. The rest you read, it's the same material, same idea. So you have 4 values, and some textbook they give you this presentation. Or some project manager they train in a different way, so they have a different presentation. For example, they put activities, They put in activity time, and then earlier start time, earlier finish time, 15, 17. Actually, the same. We just use boxes. This is another presentation. So when you go out there, when you learn, you see some project manager, when they put in numbers, at least you know this is actually what you learn. It's just that the presentation is a bit different. Okay. So if you see this kind of diagram, where you see the two numbers is the same, means it's a critical path component. And you take this one minus this one is a slack time. Okay, 17 minus 10, you have 7. It depends on the unit. Maybe 7 weeks or 7 months and so on. Okay. Okay. Okay, the rest is quite familiar. But the one that is different is that you use the 6 boxes to represent all these numbers. Okay. And similarity is that the arrow always pointing from the left, from the start until end. Okay. And it's not necessary to put the start boxes and the end boxes. It's not necessary. As long as you have the activities, start activities and the end activities. Okay. Unless you have the two activity that reach from the 2 point, like the example just now, then you point them to the end box. Okay. This is additional information. You already learned all this in the previous slides already. Okay, we learned about the forward pass, backward pass previously. Okay. The rest you read, huh? Okay. Okay. This is more on the critical path. Maximum flow. Oh. Maximum float is just maximum slack time. Or maximum you can delay the projects, or you can do something else within the activities. Okay. Another name lah. Maximum float is the maximum slack time. Okay. What else? Network replanning. This is the flow chart. Normally, you have this kind of flow chart in your FYP report. You have a flow chart, what you do from the start and then until end. Okay. Some professor, they like to look for this chart in your FYP report. Okay. Planning and so on. Okay, the rest you do it now. So by adjusting the location of the activities, you can actually reconstruct, then the length of critical path, they can change. For example, from activity 1 to 2, originally you need 3, but you borrow some resources, then you cut short the time here. But this one, because you borrow time resources from here, this one will give you more time to complete. So the differences between the diagram on the left and right is that because of the resources that you use, the time changed from 3 weeks to 2 weeks. This one become 2 to 3, but it will change the critical path. In this case, by 1 week. You see this one on the top is 15 weeks. The one on the bottom is 14 weeks. So it depends on how you adjust the resources. Okay. For module, I won't ask you to replanning this one. I won't ask you because the calculation is quite lengthy. You're not able to finish if I ask you to do replanning. unless I give you as a project or as a take-home assignment, then yes, this one will go. Right? I already have your project, so okay, assignment I'll give you maybe in week 6 and so on, right? Don't worry, it will be on the PowerPoint slides. Okay, the plannings, the rest you read, just information for you. Okay, so they are parallel network and series network. It's like what you learn in your electronic circuit, right? Series means one line, parallel means you have two parallel lines. Segmented chart means you pull out one of the activities and then you break them into more detailed network. Okay, especially you are manufacturing, then you break that specific part into another process. Okay, for example, you are a car manufacturing, you don't deal with the, for example, battery manufacturing, so you pull out the battery process in other process. Okay, this is called segmented. Estimating, this one is the one that we just completed before the break. So you have a three, most likely pessimistic, optimistic. Okay. Then the same equation just now. Okay, the mean time is A plus 4M plus B divided by 6. The same. Probability also we go for that already. Standard variation. This is just a add-on information. Okay. Then we also, from the example, we learn how to calculate the standard variation for the critical pathway just now. This is just another explanation from the diagram. Okay. Again, for our assessment, your test 2 or final exam, we will use the box, the 6-box approach. It's more tidy and more easier for me to mark. Then this one is additional information about statistics data. So this is first quadrant, I'll call it 68% of data will be here. So until the second zone, if your Z value become 2 already, the probability maximum will go 95% of the data. Then if you stretch until Z equal 3, you reach the almost maximum 99.7 of the data. So it depends on the Z value. So if your Z is 0, means you will be here. Then if your 1 is either positive 1 or negative 1, it depends on which side you are going. Right? Okay. What else? This called 95 is 2 is a 2 standard deviation, 3 standard deviation, and so on. So the rest we already go through the example, how we apply the things. Okay, the rest you read is just add-on information. The rest you read. This is all the steps when you build the network. Primary objective. Okay, this one also you read. Crash time. Okay, this one already seen the differences between PRT and CPM. Okay, now we look into crash time and the cost of the, if you crash, what will it cost you the damage? Okay, so you'll see a new presentation of data. So activity A until F, time required, normal, this is the mean time that you calculate, 462,276. This is the crash time. So time required, this is a crash time, 2 weeks, 5 weeks, 1, 1, 5, and 3. So the cost for normal activities is 10,000. If it crash, it will cost you 14,000. Crashing cost per week will be 2,000. So how do you know 1/4? The cost, the week when you crash is 2 weeks. Crashing cost per week, 2 times 2 is 4,000. You add the normal cost is 14. Yeah. So another one, for example, this one. You crash 1 week, the cost is 6,000. So 6,000 plus 12,000, you get 18,000 and so on. Same calculation. Huh? So the rest you read. The rest you read. Okay. So this is a graph that you developed from the table just now. So I'm going to very slow to how to develop this graph. This one, when you have the table and you have the diagram, how you combine this one and how you build. First, you build the axis, the program cost on the y-axis, program, the time, the completion time on the x. Okay, you build these two first. Then you go for the middle one here, the normal cost. If you add all the numbers from activity 1 to F, you get one total number, right? You add 10,000, 30,000, 8,000, 12,000, 14,000, 40,000, 20,000, you will get 120,000 and you draw this line. Okay, first you go to the table, you add all the numbers, you draw one line there. Okay. Then you have the base. Second one, you go to the crash columns. Then you build the maximum value you have here. What happens if you crash? What is the total cost if you crash all the activities from A until F? You add all these number, you get the maximum, all activity crash. You get the maximum peak, so you have the base and the maximum. So all activity crash, you have one number there, 165K. Okay, so you use your ruler, draw dash line, draw dash line. Then after that, you start to build the point that you have, assuming no new critical path, activity A, F, B would crash in order. So A, F, E, B, A, F, E, B. How we know A, F, E, B? Okay, so by the cost, by the cost. So first one, A is 2,000 only. Then F, 3,000. E, 6,000. B is 12.5 thousand. Okay, you follow the sequence A, F, E, B based on the cost in order. So let's say in this case, so the first one will crash A first. Okay. So the time of this this critical activity, these 4, you add them is 22 weeks. 23 weeks. Okay. 4A, F 6, E is 7, V is 6. So we add the critical activities together, you get 23. So you build the 23 weeks maximum time frame for the activities. Then you try to reverse back from activity A. 23 weeks, you minus 2. Normal minus crash, you get 2 weeks. So 23 minus 2, you get 21. So you get a point for activity 1, crash 1. But you don't know this point yet. You just know that here to here is the activity 1 point here. You don't know whether where is the point here. You can calculate. We find the location first. The location first. Then F. F is 3 weeks. So 21 minus 3, you get 18. So you get another point for that one. And the following is the A, F, E. E is 5. So you further reduce. Further reduce time. 7 minus 2, and then minus 5 is 2. Then minus 5 is 2. And then B time is 1 week. Yeah. So you have 4 points. 1, 2, 3, 4. Okay. Once you have that 4 point already, you start to develop the cost, because your y-axis is the cost. So for the first cost is 2 weeks. So 2 weeks just now multiplied by 2K is 4K. So you go up a little bit to 120 plus 4. You have 124K. So just now you have the X location. Now you have a Y location. You have 1 point. Then you join this point and this point. You get 1 line there. Then this is a crash of activity 1, A. You do the same for the rest. For example, another one is the F. F is 3K. 3K multiplied by 3 is 9. So 124 plus 9, you get one more number. It is 133K. All right. Then you go for another one and so on. So 133 plus this one plus this one. Okay. So you find the location of each one of the crash. Crash A from here to here, crash F here to here, crash E here to here, and crash B here to here. Okay. So what information we can extract from this graph? So if you can see, if all normal operation, the total cost you need is 120K. And if your critical path activities keep on failing from A, F, E, and B, it will cost you from 120K to 157.5K. So there is an additional cost of 37.5K. If the critical, the one that I highlight on the screen here, happen in sequence. Okay. And the corresponding time would then be reduced from the 23 to 15 weeks. 23 drop to 15 weeks. Okay. So this is just to tell you that there's a way to do it. So crashing this element would result the cost increase 7,500 without reducing the total project time. This one you study a little bit because a lot of numbers here, right? However, you need to go back to the real situation to see whether you can do something about the non-critical activities. But this estimation, sometimes it is unrealistic to do, right? This is another simplified diagram, cost versus time. So we want to avoid the wasting resources. So what we do is that we will find the shaded area by using the estimation. The rest you read. Okay. Then there are two type of costs, indirect and direct costs. What else? Lag time. This is a CPM chart. CPM chart. This is a Precedence Gantt chart. Okay, some Gantt chart, it looks something like that. And how you read the Gantt chart. So for example, task 1 and task 2 related with using solid line. And this one, you will see this kind of a presentation in the old project management software, right? So if you see solid line means it's interrelated. Task 3 and 4, they can begin when task 2 at half of the projects. For example, actually 2, you need 2 weeks, but after you start 2 weeks, 1 week, you can start 3 and 4 already. Okay. So on. Dot time means the time, the slack time that you can play around. What else? This is another Gantt chart, chart that you will see. This is a normal one, finish to start. Start to start means the start point and the start point join together. This is finish to finish means after you finish this one and you combine with the finish. Means the finish, the end date of the first activity 1, will be meet exactly the same as activity number 2. So activity number 2 can start anytime as long as the finish time is exactly the same as activity 1. Okay. Start to finish, this one is more constrained. The rest you read lah. Okay. Another one is that you will see a diagram with percentage. So for example, this one, activity 1, 50%, then constraint 20%. It means that if you see this kind of process, it means that at least 20% of activity 2 cannot be started until 50% of activity 1 has been completed. So it means that the starting point of activity 2, you cannot reach 20% unless you need to wait for activity 1 reach 50%. Okay. So you will normally see this one in the factory flow with the conveyor belt, especially those with the timing. For example, those manufacturing the cake, the food processing one. So this one, they always have a very tight processing schedule, right? And so on. So some you see very complex, something like that. Okay. Lag. So definition for lag early start finish of one activity and the early start finish of another activity. Okay. The difference between slack is measured within activities, lag is measured between the activities. There's a difference between slack time and lag time. Lag is measured between activities, slack is within the activities. So there are lots of ways, okay? And I won't ask you on lag this time. The rest will be okay. Let's do a quiz, then we call it a day. Oh, okay, we do it very fast. Okay, the shortest time possible to complete all activity in the network is called shortest time. Okay, critical path. Which of the following cannot be identified after performing a forward or backward pass? Okay, this is extra lah. Which of the following cannot be identified after performing forward pass? How much overtime is scheduled? This one you cannot. Okay. When you do forward, backward pass, you can do slack time, you can do critical path. Dummy activity is more on the AOA activities. Okay. Which of following is not commonly used technique for schedule compression? Which one? Scope, resources, fast track, use overtime, not commonly used. Is a resource reduction. Of course, this one is not inside our slides. Network-based schedule has 4 parts, 7, 8, 9, 10 weeks. If the 10-week part is compressed into 8 weeks, then what will happen? We have 2 critical paths. 9-week path is now a critical path. Only 7-week path have a slack. Not enough information is provided to make a not enough. Okay. The disadvantages of using bar chart. What is the disadvantages of bar chart? Not show dependency, ineffective, not identified start and end date. So this one is do not show dependencies. First step in developing a schedule is a what? Unique activity, effort, duration, dependency. Which one first? Activity first. Okay, you need to do what you need to do first. Okay, reducing the peak and valley of manpower assignment to obtain a relatively smooth manpower curve is called, and this one is not inside our this one, is called leveling. Okay, means you have up and down. You just find a minimum or not minimum, average that you need. It's called leveling. Activity with no time duration is called 0 1. In our previous slides, we use 0. Okay. Optimistic, pessimistic, most likely activity are associated with PERT. So you can know we focus a lot of PERT graph. Most common constraint in a precedent network is this one is finish to start, but this one is not our main focus. Network-based technique is that allow branching and looping is looping. The word is looping is graphic just now. Graphic with a back loop one. If activity on critical path takes longer than anticipated, then which one? Additional pathway will appear. Activity not and critical path will have less slack. Sure. Activity not on the critical path have additional slack. Okay. Try to think about it after the class. Okay. Which of the following is not one of the 3 types of dependency? This one is just 5 minutes ago we mentioned about this one. So you have mandatory, you have this discretionary and external. So internal is not. Okay, you have three types of dependency. Mandatory means you build the wall first before the roof. Mandatory. Discretionary means based on the experience, means at your self discretion, means you can decide which one is suitable. External is something outside control. You have an activity, you have early start 6 weeks, finish is 10 weeks. Earliest week is slack is what? You try you take the last one, right? The last I mean the six rubric, you take the last two minus, right? So how many? 8, So I think you're expert already, lah. Okay, so with this we conclude chapter 5. Friday we will go into new chapter already,